Let's move on to the last relational algebra operator today, aggregate functions. Aggregate function is one of the extended operators of relational algebra. It is very useful to apply the function to perform the computations on multi-row of columns and return a single value. It is denoted by the script F. The most common aggregate functions are sum, average, count, or count distinct, min, and max. For distinct here, we return only the distinct value by removing the duplicate. It will count only one time for the same value. Let's see example 1. In relational algebra, we write script F followed by average salary from T salary. It represents that we want to compute the average salary of all employees from table T salary. So in SQL, we can write select average G for computing the average salary from table T salary and we select none. We can run it with the shortcut key Control Enter. Here is the result from this SQL query which performs the aggregate function average salary which will return a single value. We can also give the name to the attribute. For example, we can give the name of the result of average salary as the average. We can use the keyword as and the name of the new salary is average salary. We can run it with the shortcut key Control Enter, so we get the attribute name average salary in our result. Let's move on to the example 2. In example number 2, we have dname is the grouping attribute, and we perform the sum, the aggregate function sum, to compute the total salary from table T salary on each department grouped by dname attributes. So in SQL, select dname, aggregate function sum on attribute salary from T salary and we group by dname. We can run it, Control Enter. So here's the result. We have 3 departments and the sum of salary of each department instead of all employees from T salary. In the example 1 above, we don't specify the group by attribute, so it will perform as one big group. Let's move on to the example 3, aggregate function script F with count distinct dname from T salary. It will return the number of the distinct department name from T salary. In SQL, we write select count open bracket and the keyword distinct space and dname close bracket from T salary. We can run it, Control Enter. So as a result, we got 3 distinct department names. If we don't specify the distinct, we will count all department names. So let's try another. Let's see what the difference if we just count the name and count distinct name. Let's run it. We forgot to write it. So the result here is 5. If we count the name for count distinct, we got 3 from the table T salary. Let's retrieve the data from the table T salary. We write select star from T salary. Control Enter. So as you can see here, if we apply the aggregate function count, it will count all dname. But if we use count distinct, it will count only the distinct department name. 3 distinct dname. Let's move on to the example 4. Here we have a grouping attribute dname, minimum salary from T salary on each department. In SQL, we can write select dname amount min is the aggregate function salary from T salary group by dname. Control Enter. We have found the minimum salary of each department. Let's go to the last example today is dname aggregate function max salary from T salary. We can write select dname max salary from T salary. Group by dname. Control Enter. Here is the result of the maximum salary from each department. That's all for the aggregate functions and also the demonstrations of how to translate the relational algebra expressions to SQL queries. There are more to go on the SQL query in the next lesson.